Section number 45 is entitled General Rules of Exponents. Many of these we already know. The first rule is if you have a product and you raise that product to the nth power, you can take the individual factors, the things that are being multiplied, x and y, and raise them to the nth power. To direct it, if you had many things, a times b times c times d, and you're raising it to the nth power, you take the individual bases, a, b, c, d, e, f, as many as you have, and you raise each of them to the nth power. The reason why this is true, we'll look at this example. If you have xy cubed, well, that means xy times xy times xy. So we're multiplying 6 things. And the order you multiply is up to you. You can multiply the x's first, and then multiply the y's last, and then you'll get x cubed times y cubed. If somebody asked me to multiply 25 times 2 times 3 times 7 times 4, I definitely would not run and go and get my calculator because that would take too much time. I would say, I love 25 times 4. And then I would do 2 times 3 times 7. And in my head I would say, well, that's 100, and 2 times 3 is 6, times 7 is 42. 42 times 100. Oh, I know that one. That's 4,200. Okay, the order you multiply is up to you. You want to go 25, see if I can do this. 25 times 2 is 50. 50 times 3 is 150. 150 times 7 is 1050. And 1050 times 4 is 4,200. It was hard for me. It was hard for me. But if I group it more friendly, like 100 times 4 times 7 is 42, 4,200, I can do these things in my head. Stop running for your calculator. You have better things to do than waste your time with your math homework. Wasting extra time doing your math homework, like running to get your calculator. I'd rather be done sooner. Okay. Rule number 2 is very similar to rule number 1, but instead of multiplying x and y, we're going to divide them. If you have x over y to the nth power, well, this is x to the n over y to the n. This one is a bit more obvious that it's true. Because if you have, say, x over y cubed, this means x over y times x over y times x over y. And you don't even have to regroup. The numerator is obtained by multiplying the numerators and denominators. You multiply the denominators. When you multiply the numerators, you get x cubed, and the denominator is y cubed. Okay? It says if the powers outside distribute. X to the n, y to the n. And those are definitely 2 rules that you need to know. Now, if you recall that a to the b raised to the c power will Okay, you multiply the exponent. So now, if you had, remember, we said that x times y, one thing times another thing to the nth power was the first thing to the nth power times the second thing to the nth power. Now, if the first thing, let me not call it x. If the first thing is r squared times the second thing is s cubed, if we raise this to the fifth power, well, think of that whole thing, r squared as x and s cubed as y. Well, we're supposed to get x to the fifth times y to the fifth. That is, we get x squared to the fifth times s cubed to the fifth. And using the rule right above, we multiply those powers. R to the 10, s to the 15. Now, question is, could we have gotten to the end a little bit quicker? And like I said, s to the 15, so maybe it'd be best if I write that. Could we get to that end a bit quicker? The answer is yes. 5 times 2 is 10. 5 times 3 is 15. How I view these problems is, if somebody asked me to do this problem, I would take it as, oh, they're asking me 3 separate multiplication problems. They're asking me, what's 2 times 7? And they're coding it. They want me to put the answer by the x. And 3 times 7, 21. And 9 times 7, 63. To me, they were asking me 3 multiplication problems at once. What's 2 times 7, 3 times 7, 9 times 7? 14, 21, 63. It's up to you to spend the time to remember that this is multiplication. I'm sure you know your multiplication table, but yet you may get these wrong because you didn't know to multiply. Now, I said a number of times, what's in the parentheses must be multiplied. If you have x squared plus, that's not multiplication. If you have x squared plus y to the 3 to the 7th power, this is not, say, x to the 14. 2 times 7 was 14. Plus 3 times 7 is 21. It is not that. It is not that. After all, 5 is 2 plus 3, which is 2 to the 1 plus 3 to the 1. And if I happen to cube everything, well, 5 times 5 times 5 is 125. This is not equal to 3 times 1 is 3. So 2 cubed plus 3 times 1 is 3, 3 cubed. Which is 2 cubed is 8, plus 3 cubed is 27, and 8 plus 27 is 35. 125 does not equal 35. It falls apart right there, right there. You cannot do that over addition. You cannot multiply the 2 and the 7 and the 3 and the 7 because we were adding or subtracting. It wouldn't work. Only if you are multiplying. Only if you are multiplying. Now, I've said a number of times that final answers, unless otherwise stated, final answers should only have negative exponents. it shouldn't have negative exponents. I don't want to say positive exponents, but I want to leave out the possibility of the exponent being 0. The final answer should not have negative exponents. Now, if you rewrote what's inside the parentheses with only negative exponents, only positive exponents, like a squared stays where it is on the top, but b to the negative 3 goes on the bottom. Now, if the exponent outside was positive, that wouldn't be such a bad idea, because 2 times 2 is 4, and 3 times 2 is 6. Okay, with division, you can also distribute the power out front. You multiply the powers by the 2. And then the final answer will have positive exponents. But what if we have this same problem, except the power outside is negative? If I got everything inside the parentheses to be positive, when I go and multiply by the powers by negative 2, when I go and multiply the powers by negative 2, I get only negative exponents. And then you move top to bottom, bottom to top, and you get b to the 6 on top and a to the 4 on the bottom. But we could have been done right here if we'd be a little bit more clever. I don't want these exponents to be positive. I want them to be negative. That way, when I multiply by negative 2, they'll become positive. So now, believe it or not, I want to rewrite what's in the brackets with only negative exponents. Why? So when I multiply them by the negative 2 outside, they'll become positive. Negative times a negative is positive. The a to the 2 has a positive exponent. Not good. It's in top. I'll move it to the bottom to make it negative. B to the negative 3, it already has a negative exponent. Leave it just where it is. Raise it to the negative 2 power. Now when you multiply those two exponents, they become positive. When you multiply these two exponents, it'll become positive. Yes, we got the same answer as before, but it took us one less step. So sometimes, believe it or not, you want the exponents to all be negative, but not at the very end. No matter which way I did the problem, I got b to the 6 over a to the 4. My final exponents were always positive. But in the intermediate step, I may want them all to become negative. So let's work on these problems. Now, since I'm raising it to the 3rd power, raising it to 3, which is a positive number, I would love everything inside to have positive exponents. Fortunately, I know my 7 table well. 7 times 2 is 14. 7 times 3 is 21. That is, I divided 14 and 21 by 7. So I have 2 over 3. When it comes to the a's, the larger power is in the bottom. And then I subtract them. I compute 2 minus negative 4. Or I think it won't hurt. How far apart are these two numbers? And please, they're not 2 apart. If I go 2 to the right, I'm at 4, not negative 4. And if I go 2 to the left, I'm at 0, which is not negative 4. They're not 2 apart. Well, from negative 4 to 0 is 2, and from 0 to negative 4 is 4. They are 6 apart. The larger power of the b is on top. What is the larger power minus the smaller power? I mean, you can just go 3 plus 7, that's fine, or 10. And now we need to raise this to the third power. Well, 2 cubed is 8, and b to the 10 cubed is b to the 30. 10 times 3 is 30. 3 cubed is 27, and a to the 6 cubed, well, you multiply the exponents, and you get a to the 18. And then notice, and then you should ask yourself, am I done? And you can't reduce 8 and 27, and all the exponents are positive. So yes, you're done. And let us consider this next problem. Suppose you have b squared, c to the negative 3, d to the 4th, e to the negative 5. You want to raise this to a negative exponent. That means you want it to be beneficial if all the exponents in the parentheses were negative. Well, the bases are all different. B, C, D, and E. They're all different. So we can't combine any, so we just move or don't move. B to the negative 2, we move it. Times, and not being added. C to the negative 3, it stays where it is on the top. D to the 4, it has to be moved to the top as D to the negative 4. E to the negative 5, it can stay where it is in the bottom. Now, when I multiply the 3, the negative 3, the negative 4, the negative 2, the negative 5, when I multiply it by good old negative 3, positive exponents. 9, 12, negative 2 times 3 is 6, negative 5 times 3 is 15. And here is my final answer, and all the exponents are positive, which is just what we wanted. Remember, a smaller number minus a larger number will always, always, always be negative. If you take away more than you have, you'll be negative. So suppose you have a to the negative 2, b to the 4, c to the negative 7, over b to the negative 11, c to the negative 3, a to the negative 4, and this is all being raised to the negative 4 power. Since it's being raised to a negative exponent, that means I want all the exponents inside the brackets to be negative. So when I multiply those powers by negative 4, they'll become positive. These bases are the same. And since I want a negative, I want to do smaller minus larger. Then negative 4 is smaller. How much smaller? It's 2 smaller. The difference is 2. But since we're doing smaller minus larger, it'll be negative 2. Negative 4 minus a negative 2, if you work it out, it's negative 2. B. The smaller power is on the bottom. And since I put B in the bottom. Since I'm doing smaller minus larger, it'll be a negative answer. Negative what? Well, how much bigger is one than the other? I hope you realize they're 15 apart. If you want to do negative 11 minus 4, you have every right to read it backwards, but then you have to put a minus sign in front. This is 4 and that's minus, but that's not 11. So it's not 4 minus 11, so it's 4 plus 11, which is 15, so the answer is negative 15. When it comes to the C, the smaller power is on the top, and it is 4 smaller. If you do negative 7 minus negative 3, well, this is negative, it's not negative 7 minus 3, it's negative 7 plus 3, which is 3 plus, it's negative 4. Negative 7, add 3. Since I ran out of space on the bottom, I'll put the final answer above. But now you just multiply the exponents. -4 times -4 is 16. -2 times -4 is 8. -15 times -4 is 60. And there's the answer. Sometimes you want to get negative answers, negative exponents. Inside here, by design, I got negative exponents. Instead of doing larger minus smaller, I do smaller minus larger. Remember, if you read this backwards, if you really prefer to do larger minus smaller, do so. But then you get a negative in front. Okay, if you rather do 4 take away -11, 4 take away -11 and say, well, it's not 4 take away 11, it must be 4 plus 11 or 15. Fine. Fine. Instead of doing -11 minus 4, you want to do 4 take away -11. Fine. And then you get a minus in front. And since that's 15, you just get -15. You can do larger minus smaller, fine. But don't forget to put the minus in front. Okay, that completes the section on general rules of exponents. Good luck with it.